Hello everyone, I'm Heysem Askan. Today I'm going to talk about factorials, combination and binomial. Okay, let's start with factorials. What is the definition of a factorial? A factorial is a specific number is a positive integer, and n factorial is the multiplication of positive integers from n, the specific number given, to 1. For example, the specific number is 7. So 7 factorial is equal to 7 times 6 times 5 times 4 times 3 times 2 times 1. So it is all the positive integers, multiplication of all the positive integers from 7 to 1. So the answer is 5040. I would like to give a little note here. 0 factorial is always equal to 1. So let's give an example. This is another example of how we can do it. So let's say n plus 3 factorial. How do you solve it? Answer is n plus 3 times n plus 2 times n plus 1 times n negative 1. So as you can see, each time we minus one number. So it was 3, it became 2, and it became 1, and it became 0, and then it became negative 1. So we minus one number each term. So let's solve an example here. It says write the first two terms of the sequence an is equal to 4 times n plus 3. So when we say the first two terms, we are talking about a1 and a2. So a1 is equal to 4 times, replace n with 1 plus 3. So we solve this factorial. 4 times 4, 3 plus 1 factorial is equal to 4 times 3 times 2 times 1 is equal to 96. So what we did here was to expand the factorial and we multiplied by 4. Second factorial. 4 times 2 plus 3 factorial. So we again replaced n with 2. So 2 plus 3 is 5. So 4 times 5 factorial. It is 4 times 5 times 4 times 3 times 2 times 1. So any positive integers between 5 and 1 times 4 is equal to 480. Alright, here is the rule. n factorial is equal to n times n minus 1. We use this rule when we want to simplify the factorials. Okay, so this is an example. Simplify the following. 5 factorial over 3 factorial. So here you can do this. Alright guys, so you can do 5 times 4 times 3 factorial. Let's get our pointer. What we did here is the same thing. I mean, it is 5 times 4 times 3 times 2 times 1. If we had expanded in the normal way, it would be like this, right? But we only need until the 3 factorial. So we stop here. And instead we do 3 factorial. So then we can now here cancel this and this out, which gives us 5 times 4, which is 20. Alright, this is the end of the factorials. Now let's go to combination. For example, let's say I have 20 apples and all of them have different colors, okay? So let's put our pointer on again. So I have 20 apples and all of them different colors. Let's say blue, let's say red, let's say green, and 20 more colors. So I randomly choose 10 of them, just randomly. It might come anything. It might come yellow, it might come green from these 20 apples. So the formula of this is n choose r. N is the number of elements in the set, and r is number of objects that we choose from the set. So how do we find n choose r? N choose r is equal to n factorial over r factorial times n minus r factorial. So let's give an example of this. Let's say 4 choose 3. So on top there will be a 4 factorial. At the bottom there will be 3 factorial r. This is n 4 factorial times n minus r 4 minus 3 factorial. So then it will become 4 factorial 3 factorial times 1 factorial. So 4 factorial is, do you remember that we showed the last PowerPoint? It was 4 times 3 power. We can do this instead of doing the full thing if we want to cancel out. So that's what we do. 3 factorial times 1 factorial is equal to 3 factorial. So 4 factorial is equal to 4 times 3 factorial. So now we cancel out the 3 factorials, which leaves us with the 4 in here. So the answer is 4. Alright, let's say you're in an exam and you really do not have time to use the formula. There's always the short way. So instead of using the formula, you can use this. N choose R is equal to N choose N minus R. So for example, N choose 3 is equal to 4 N choose 3, which is N is 4. 4 choose 3 is equal to 4 choose 4 minus 3. So what is the answer? 4 choose 1, which is equal to 1. So let's see if it's the same. Let's do it with the long way. So which is, let's use the formula, which is n factorial over r factorial n factorial choose by r factorial times n minus r factorial. So let's use this one. So n is 4 factorial, choose by r is 3 factorial, times by n is equal to 4 minus 3 factorial. So let's see if we are going to get 1 also. So 4 minus 3 is equal to 1 factorial. So then it would be 3 factorial times by 1 factorial, which is equal to 1 factorial, which is equal to 3 factorial. So it will be 4 factorial over 3 factorial. We did this on the last PowerPoint. So then this would be equal to 4 times by 3 factorial over 3 factorial, choose by 3 factorial, 3 factorial, 3 factorial. The answer would be 4. So did we get the same one? Yes, we did. The answer should be 4. It was my mistake, sorry. Okay, now let's move on to binomials. Alright, let's see the definition of a binomial. Polynomials with 2 terms is the definition of binomial. For example, z plus x. Z is a polynomial, so z plus x is a binomial. So a plus b powered by 0 is, these are the examples of binomials that I would like to give. Let's get our pointer back. These are the examples. So a plus b power 0 is equal to 1, a plus b power 1 is equal to a plus b. As you can see, the power increases. As you can see it here, the power is 0, and then 1, and then 2, and then 3. Also these numbers. And there is a specific order in this, which we will learn right now. So, do you know how you could do this? We could see it if we can look closely at Pascal triangle. This little thing will help you in exams. This will save your life. Alright, if we can look at this triangle closely, this is the power 0 one. So this is power 0, this is power 1, this is power 2, this is power 3, 4, 5, 6, and 7. So as you can see, these increase. So for example, 1, 1, 1, all ones go down. It is 1 plus 1 is equal to 2, 1 plus 2 is equal to 3, 2 plus 1 is equal to 3, and 1. Look at this now. This is power 3, right? Look at the magic. 3, 3, 1, 3, 3, 1. For example, order 2, 1, 2, 1. Look at this. 1, 2, 1. So there is a specific order in this binomial theorems. So what if we are given a formula and asked to find a specific coefficient? This is later on. First, I would like to talk about the powers also. So as you can see in here, let's get our pointer back. Pointer, this is A3, and then that becomes A2, and then that becomes A1, and then that becomes A0. So at first it was A3, A2, A1, and then A0. As we can see, it decreases throughout. And then look at the B. It was B0, the second coefficient, B0, B1, B2, and gradually B3. As the first subject, the A decreases from, starts with 3 and decreases to 0, and then B, the second object, starts with 0 and increases to 3. Alright, this is the triangle. Okay, what if, let's get our pointer back. What if we are given the formula and asked to find a specific coefficient? Like, to find, for example, we are given A plus B square, and then they said find the coefficient of A square B. Now we have to cope with it and find it. So this is the formula which you can find it with. And choose R times by A n minus R, A power n minus R times B power R. So find the coefficient of, this is an example, find the coefficient of x squared b in the formula x plus b cube. So let's do the formula. Rn is 3, choose R. We don't know R yet, we're trying to search for the R. X n minus Rn is 3, so it's 3 minus R, and B choose R. We don't know R, B choose R. If this is the case, if it's 3 minus R, the way we find R is this. 3 minus R is equal to 2. We take this number, 2. So it will be 3 minus R is equal to 2, and then we move R, we must make R alone, so we move R here and 2 to the other side. It will be equal to 3 minus 2 is equal to 1, so R is equal to 1. So we replace R with 1, so 3 choose 1 times x, 3 minus 1 times b, 1, which the answer will be 3 times x power 2 and b power 1. So the coefficient in here is b. So the answer of this, the coefficient in here is 3, I'm sorry. So the answer is equal to 3. So this was the end of my presentation. This was a brief idea that I gave you about binomials, factorials, and combinations. I hope you enjoyed the presentation, and I thoroughly hope that you have learned something from this presentation, which was my goal by doing this presentation. Thank you.